to go over lesson 7.2 over similar polygons. So last semester, during semester 1, we talked about congruent polygons. Congruent polygons have all equal sides and all equal angles. And this is an idea from last semester, so we need to distinguish between what we're doing this semester. This semester, we have something called similar polygons. Similar polygons, here's some keywords. They have the same shape, but they may or may not have the same size. So it's like you go to a copier and you put a picture on the copier, let's say a rectangle, and you could blow the rectangle up to, let's say, a bigger, like 200, 300%. You can blow that up bigger. You could shrink it, but it still stays a rectangle. It doesn't turn into a different shape. So all of those shapes would be similar because they're all the same shape. They're all rectangles, but they're not the same size. So as I go through here, these circles are exactly the same. So they are congruent and they have the same size. So they are congruent. So this is the idea from last time. Now for similarity, let's look at the triangles here. These triangles, they are the same shape, but they are different in size. So that means they are showing some similarity. So let's go down to this definition. Two polygons are similar if their corresponding angles are congruent. Corresponding means the angles that are in the same place as the other shape. And we'll talk about that more. And we also have corresponding side lengths are proportional. And again, we're going to talk about all of this in detail. When we look at the yield sign, if you notice one is bigger than the other, they're both triangles, they're both the same shape, but they are different sizes. If we list the corresponding angles, we would say the upper left-hand corner of one, let's say A, is going to be corresponding sides or corresponding angles are congruent. So we're going to set that equal to the upper left-hand angle, which is angle D. Angle B is the upper right-hand corner, so that's going to be equal or congruent to angle E. And then we have angle C, which is going to be congruent with angle F. We have a new symbol for similarity. It's just a little tilde part that's on top of your congruent symbol. So whenever you're talking about similarity, you can just use the symbol. And that's just something that you could do that's for ease, so you don't have to spell the word repeatedly. Now, last semester we had congruency statements. Similarity statements are exactly the same thing, except for now we're going to use the new symbol, and it's just to show that the two triangles are similar. So if I were to do this, I would have to put them in the same order as I just did the angles. So the first triangle, it really doesn't matter which order you go in. So I could say ABC, CBA, BAC. You just choose and put the letters in order. It doesn't make a difference. Now I'm going to use my new symbol for similarity. And then for the second triangle, I have to match up locations. I have to use corresponding angles. So what corresponds with A? We just practiced this. A corresponded with D. B, if you remember, corresponded with E, and C with F. So that's a similarity statement. So let's go through here and practice some more. Example 1. Now they provide you a similarity statement right here that's in yellow. So really without a picture, I know angle A is going to be congruent with angle E. So let's look at the picture. Is that true? Angle A here is the same as angle E, and it is. If I said, hey, what corresponds with angle D? You could easily just look at it and say, oh, that's the last letter. The last letter here is H. So D and H are corresponding and congruent. And that is true. Here's D, here's H. They're corresponding and congruent. So we're going to fill in the blanks. And it's just matching up the angles. You don't even need the picture. You're looking at the similarity statement, and that can really just give you all the answers that you need. So A, the first letter, what does it correspond with? And that would be angle E. B, the second letter, corresponds with angle F. Angle C corresponds with angle G. Angle D with angle H. All right, so one thing I forgot to do above is to show the second part. We need to show that their corresponding sides are proportional. So that is part of proving that they are similar. So I'm going to look at my picture again, and let's get rid of some of these markings. I'm going to pick corresponding sides. Now I'm going to say A to B is corresponding with what side? And again, you're using your similarity statement. What corresponds with A? Well, that was E. What corresponds with B? Well, that's F. So I'm going to write in the answer EF, and notice it's already here for you. So the next one is FG. All right, so I'm going to outline that. What corresponds with FG? Well, if you look over to the next figure, that's BC, or you could use your similarity statement. So this is BC. For GH, what corresponds with it? And that is CD. And lastly, EH is the bottom. And so I'm going to say A to D. So guys, you do have to prove both of these things. There are two things here that we proved. One, that the angles are congruent, the corresponding angles, and two, that the corresponding sides are proportional. So let's keep going. What we're going to do is we're going to determine if these shapes are similar. So we have to prove two things. First, the corresponding angles are congruent, and that the sides are proportional with each other. Okay, so on the first one, can we prove that these angles are all corresponding? All right, now A corresponds with N. They're both 90. That works. R is corresponding with T because there's congruent marks, and that works. I really don't see any markings up here for the other two angles. Now, I'm able to mark them as congruent because we have a thing called the third angle theorem that says in a triangle, if two angles are the same, the third angle also has to be the same. So I can prove all three of these angles are corresponding and congruent. So do we have congruent angles? Yes, we do. Check. Now, do we have proportional sides? Okay, now this involves some work. You're going to make three proportions. Okay, so now it doesn't matter which one you start with. You can start with any side that you want, the big triangle, the small triangle. I'm just going to start with the 9. And then say, what does 9 correspond with? And that is a 6. And then I want to go to this 12 and say 12 corresponds with what? And that is the 8. And 15. 15 corresponds with 10. Now we're not finished yet. What we have to do is you have to grab a calculator and start dividing. What's 9 over 6? Well, guys, that's 1.5. What's 12 over 8? That's 1.5. What's 15 over 10? That's 1.5. So you have to check these numbers. These numbers are your scale factors. They have to be growing at the same rate. So if they all are growing or shrinking at the same rate, then the sides are proportional. So are the sides proportionate? Check. So let's go back to the directions. If so, write a similarity statement. So again, you're going to pick a triangle. Doesn't matter the big or the small. Put it in any order you like. I'm going to say XAR. Put your new symbol. And then look at the small triangle and put them in the same corresponding order. So X corresponds with M, A with N, and R with T. So we're finished. Now, if you are able to prove the angle and the sides here, we would not write the similarity statement. So we'll have examples here in just a moment. Okay, moving on. Example B. Can we prove all the sides? Sorry, let's start with the angles. Can we prove all the angles are congruent? Well, sure, because they're all 90. That's easy. If they're all 90, then sure, check. All the angles are congruent. Now let's check the sides. Let's find some room here. 10. What does 10 correspond with? Look at the other figure. The other figure, it's 8. So 10 over 8. And then we have a 6. Now notice I started with the 8, which is on the big figure. I have to continue to start with the same figure. So that's the 6 and a 4. Now, if you keep going around the figure, notice there's another 10. Is there really a need to write 10 over 8 again and to write 6 over 4 again? And there's really not a need because you're going to get the same answers as you have previously. So it's fine if you leave those two off. So the moment of truth, let's divide these out and see if you get the same scale factor to see if they are proportional. So let's see. The first one I get 1.25 and the second one I get 1.5. So that means they're not exactly the same shape. One side's growing at a different rate than the other. So are the sides proportionate? No way. They're not proportional. So you're not going to write a similarity statement. So I'm just going to say not and use my new symbol, similar. Okay, for letter C, I'm going to prove that all the angles are congruent. Let's see. L is congruent with T because I look at the markings. M with P. And then can I prove the other two? And I can because, again, of that third angle theorem that tells me these two angles are the same because the other two are the same in a triangle. This rule only works for triangles. So are the triangle angles congruent? Check. Now we have to check the sides. Are they proportional? Now I'm going to show you my little trick to make this easier and faster. I pick a triangle, whichever triangle you want to start with, and I find the shortest side, which if I use the big one here, the smallest side is the 6. So let's just write them from smallest to greatest. The next is the 8, and the next is the 12. Let's do the same thing with the small triangle. What is the smallest side? And that's 4.5. What's the medium side here? 6. What's the largest side? 9. That's a weird 9. Okay. So what do? Are they proportionate? Well, we don't know yet. Take a calculator and start dividing. I get 1.3 repeating. 1.3 repeating, looking good. And 1.3 repeating. So grab a calculator. You could check it yourself. They're all the same. So are the sides proportionate? Check. Yes, they are. So are we finished? Of course we're not finished because they're proportionate, which means we have to write a similarity statement. Okay, so I'm going to write a similarity statement. Pick a triangle, any triangle, write in any order that you like. I'm going to say LMN, put your new symbol. Now, you have to use the markings. Remember, N is the same as O. I went in the order of L, M, N. So I went from the two little marks to the one mark with a line through it. You need to go in the same order. If it helps you, you can draw the little arrow on the outside as I did. I'm going to match this up with TPO. That is my similarity statement, and I am finished. Now, I've already kind of explained scale factor a little bit. Scale factor is at the rate something is growing or shrinking. This definition says it's the ratio of the corresponding sides of two similar figures. It is also what you have to multiply the sides by to obtain the new length of the new figure. So let's just jump into example 3. What do we know? We know ABCD is similar to EFGH. So things that we know, that means all the corresponding angles are congruent. We know the sides are proportional. We know all of that because they tell you right there they're already similar. So they're asking, hey, what's the scale factor? Okay, so things we need to know. Side note, if your scale factor, and usually they use a K for scale factor, and I mean, it's just one of those math things you have to memorize. K is scale factor, M is slope. It's just a letter, and it's an abbreviation for that letter. Okay, so K means scale factor. So first of all, let's establish that. If your scale factor is more than 1, this is like you're at the copier and you're blowing up a picture. You're making it bigger. So if your scale factor is more than 1, this is when you're enlarging. If your scale factor is equal to 1, this is like your picture just stays the same. Now, if your scale factor is less than 1, this is a shrinking. So it's all about the scale factor. Is your scale factor, are you getting bigger? Are you getting smaller? Or are you shrinking? Okay, so if ABCD is the original figure, then we enlarge it by a scale factor of blank to get EFGH. Okay, so what they're trying to show you here is we have we have 4 and we have like a 12. What would you have to multiply it by? What number to equal 12? So hopefully you guys know what times 4 is 12. And if you don't, I mean, you could even write this little equation. 4 times what is 12? So that is 3. My scale factor is 3. So K is 3 because each side is being multiplied by 3. The 6 is being multiplied by 3 to get 18. The 3 is being multiplied by 3 to get 9. And we already practiced the 12, but 4 times 3 is 12. Okay, so this means it is an enlargement because the scale factor is bigger than 1. All right, so we're going to go to Kinko's or someplace that enlarges pictures, and we want a poster. And what would be the scale factor of this picture? All right, so we have a picture that's 3 by 5, and we want to go to 16 by what? So how would we do this? Let's think about maybe doing a problem where we write a cross multiplication problem. So we say like 3 times 5 or 3 over 5 equals 16 over W. Now, can we solve for W? And we can. Sure, we can cross multiply. 3W equals 80. And then we're going to divide by 3. And so my width now has to be 26.6 repeating. Okay, that was easy to do. What would be the width of the poster? What would be the width of the poster paper have to be so the paper didn't get squished? Oh, you know what? I answered the wrong question. All right, so I just did part B. Part A says what would be the scale factor? Okay, sorry, let's back up. What would be the scale factor? So from the original to the new one, is the picture getting bigger, smaller, or staying the same? Well, obviously the picture is getting bigger, so that means the scale factor has to be bigger than 1. Okay, so if my scale factor is bigger than 1, I have to have two sides that I compare. So what two sides do you know both of? Well, I know this side that's 3. I know this side that's 16. So my scale factor is simply just a fraction. So, you have two choices. You have the choice of 16 over 3 or 3 over 16. Now, guys, one of those equals something more than 1, and one of them equals a number much less than 1. So you have to know. If it's an enlargement, we need the number that's more than 1. If you don't know, grab a calculator and try it. What's 16 over 3? And what's 3 over 16? Well, 16 over 3 is 5.3 repeating. So that's your scale factor. 3 over 16 is 0.1875, so that is not. So what is the scale factor? Let me write it where you can actually read it. It is 16 over 3. Okay, sorry, we already did B, so let's move on to number 5. Okay, so we need to find X and Y. Now, they tell us they're similar. So what does that mean? That means all the sides are proportional. So we could write 3 proportions. Okay, so pick any triangle, pick any side to start with. I'm just starting here on the left. 6. What does 6 correspond with? The 6 I have outlined here. Well, it corresponds with the X. What is the 8? Now notice I started with a small triangle. I have to continue to start with a small triangle. 8 corresponds with Y. And then lastly, 4 corresponds with 6. So I'm going to cross multiply here. Now they're all equal with each other, so you're able to cross multiply these in any order. So I can cross multiply these two together and solve for Y, no problem. So let's try this. 8 times 6 equals 4 times Y. So 8 times 6 is 48. And divide by 4, so Y is 12. Now you have two choices. You can either cross multiply the 2 there, or if you wanted to rewrite it, you could even cross multiply the first with the last. And this is up to you. They're all equal with each other, so it really doesn't matter. So since I took the time to rewrite it, I'm just going to use this one. 4 times X is 4X. 6 times 6 is 36. So I divide by 4, and I get X is 9. Okay, so you can check this if you want to. You could take your calculator. It takes you just a moment and say, what's 6 divided by 9? Hopefully you get 0.6 repeating. What's 8 divided by 12? And guess what? You'll get 0.6 repeating. What's 4 divided by 6? 0.6 repeating. So guys, your scale factor here is 0.6 repeating. Or you could say 2/3 if you reduce your fraction. Okay, moving on to part B. And a couple things we need to notice. This is called a parallelogram. And one rule of parallelograms is opposite sides are equal. So if the 16 is the top, the bottom, the Y, has to also be 16. So that's like a freebie. To solve for the x value, again, I'm going to write two proportions. I'm going to say, okay, what corresponds with the 12? Well, that's the top. So the other top is the 16. Then I go back to the first figure and I say, okay, I have x. What does x correspond with? And that's 18. So let's cross multiply. 16x equals 12 times 18. So 16x equals 216. I divide by 16 and I get 13.5. And that's it. I solved for x, I solved for y. Done. Okay, so we're almost finished here. Just stay with me a couple more minutes. Okay, so for example number 6, see the figures to the right. What is the scale factor from RSTU to LMNO? So I'm starting with the big figure and I'm going to the small figure. So does that mean my scale factor is more than 1, less than 1, or equal to 1? So I'm starting big and going smaller. So it's getting smaller. So my scale factor, guys, it has to be less than 1. It has to be. So find two sides they both have in common. Well, I see they both have a 3 in common and they both have a 2. So is your answer 3 over 2 or 2 over 3? Which one has an answer that is less than 1? And hopefully you're saying 2/3. 2/3 equals 0.6 repeating. So my answer is just 2/3. Now, let's erase this arrow and go the other way. Now I'm starting with the small figure and going to the big figure. It's getting bigger. So that means my scale factor is more than 1. So how should I put the 3 and the 2? Well, if 3 over 2 equals 1.5. So for your scale factor, I'm okay if you put it as a decimal or a fraction. Honestly, either one, as long as you enjoy what you're doing, I'll take either one. All right, last one. A certain map has a scale of 1 centimeter equals 250 miles. Okay, so I'm going to write this as a fraction. 1 centimeter, 250 miles. Okay. So if two cities are 5.6 centimeters apart on the map, how far apart are they in real life? Now, notice I labeled. Labeling is important. Notice I put the centimeters, I put the miles. Where should I put the 5.6 centimeters? If you labeled, it's really easy. The 5.6 centimeters goes on top, and your variable goes on the bottom. So let's cross multiply. 1 times x is x. So 250 times 5.6. Let's see, 250 times 5.6 is 1,400 miles. All right, that's it. And let me know if you guys have any questions, and have a good day.